Hello and welcome to the Algebra 2 Test for Study Guide. My name is Mr. Sipple and we'll be going through 10 problems, a total of 30, but 10 problems that match the questions that are going to be on the test. So we'll go through this first, you retake the test, and then hopefully you feel good about it. The key with this study guide, before we get started, I just want to mention that you want to try to do as many of these problems by yourself without the assistance of the video. So, for instance, if some of these problems you feel like already know how to do some of them, go ahead and do it. The idea of the video is that you're able to fast forward, pause, rewind. So for instance, if you didn't quite get something, you can go back. Whereas if you feel pretty good about something and you want to move forward, then go ahead and move forward. So that's the idea with the video. Well, let's go ahead and get started. And real quick before we do that, let's just make sure we got our name on our paper so we know who you are. So for name, just go ahead and write in your name. And then if you're coming from a different teacher, some of you are my students, but some of you are coming from a different teacher. If you are, for period, if you'll just write your teacher's name. Your teacher's name. Alright, well, let's just go ahead and jump right into it. So if you take a look at the first problem, you see the picture over there on the right hand corner. I got picture of that expression, apples to apples, oranges to oranges. The idea is that you're combining things that are the same. So an apple is different than an orange is. We can combine apples, combine oranges. It's kind of the same idea with x squareds, x's, and then numbers, is that those are not like terms. So we can only combine things that are like terms. Now, before we get started in combining these like terms, you'll notice that there's a number on the outside of the parentheses. So anytime you see a number on the outside of the parentheses, that means that it's being multiplied. And to make sure that I get this whole thing correct, I'm going to circle the -2, and then I'm going to draw an arrow to where I'm distributing. So I'm going to drop a -2 off there, and I'm going to drop a -2 off there, and drop a -2 off there. So I would encourage you to draw the arrows. It may seem a little silly, but the idea with drawing the arrows is that you make sure that you multiply everything, because it's real easy to forget something. Alright, so what I'm going to do, and actually just so I can line this up, is that after I distribute, I'm going to write what I get here. -2 times 4x squared, which would be a -8x squared. And then -2 times -7x, which would be 14x. And then -2 times 3, which would be a -6. And then what I'm going to do is I'm just going to add these things up. Now, we are adding, so don't change the exponents. We're adding the numbers, so 2 negatives and 8 more negatives would give me a total of 10 negatives. And these are x squareds. Now, if I multiply, that's when x squared times x squared would be x to the 4th. But in this case, don't change the exponents. 4x plus 14x, well, that means I'd have a total of 18 of them. And then -5 plus a -6, which would be a -11. And all they want us to do on this particular problem is just add them, just combine them. That's it, not having to solve for anything. So that would be as far as we would take it. -10x squared plus 18x minus 11. Alright, so go ahead and pause the video now, and you try the first one in the middle. Alright, well, let's see what you got with number 1 in the middle. Same story with having to distribute first. So I'm going to circle that -3. And part of the reason for circling is just to make sure that I get the negative in there as well. I want to know that it's a -3, not just a +3. Alright, so let's distribute that around. -3 times +5, right? So that would be a -15x squared. -3 times -8x would be a +24x. Remember that when you're multiplying, same signs positive, different signs negative. So -3 and a +5, those are different, which is how we ended up with the -15. -3 and a -8, those are the same, +24. And then -3 times 2, signs are different, so that would be a -6. Alright, so let's line them up and add them up. So -4, -15, that means I'd have a total of 19 negatives. And if I had 6 and 24, now I've got 30 x's. And if I've got -1 and -6, now I have a total of -7. So should have a total there of -19x squared plus 30x minus 7. Go ahead and pause the video now and go ahead and try number 3 on the right side. Okay, well, let's check to see what you got with number I say number 3 on the right side? I don't know. Maybe number 1 on the right side. Hopefully we got that right. Number 1 on the right side. So let's circle that negative 4. I'm going to distribute it out. I'm going to mix it up this time. Fill a little purple. Negative 4 times 5. So we'll do a negative 20x squared. Negative 4 times negative 3x. That would be a positive 12x. And negative 4 times 9, which would be a negative 36. And by the way, you don't necessarily have to line it up the way that I'm doing it, but I would really encourage you to do that, because what we're trying to do is we're trying to make sure we line up our x squareds, line up our x's, and then line up our numbers. So I think it's a safe way to hopefully try to prevent yourself from making a mistake. 6 plus 12, all right, 18. And 2 and 36, which would give you 38, right? Negative 38. So you'd have a total there of negative 23x squared plus 18 minus 38. All right, well, so let's go ahead and take a look at the second problem. Now you notice that there's 3 groups, and they're all parentheses that are touching one another. So you know that when parentheses are touching, that means to multiply. Now, if you look over at the right-hand corner here, I have a little diagram for FOIL, and so if some of you are FOILers and you like to FOIL, you can certainly do it that way. The way that I'll be showing on the video here is another method of solving this particular kind of problem. It's called an area model, and it uses boxes, right? Or maybe you've heard of it as the box method. So if you're a FOILer and you like to FOIL, FOIL away, stick with it. But just for purposes of here, because I'm not going to work the same problem 14 million different ways. So for purposes here, I'm going to use the box method, but again, if you like to FOIL, FOIL it out. Now you notice there's 3 groups. Well, we can only do 2 things at a time. So what I'm going to do is I'm going to multiply the first 2, get an answer, and then whatever that is, I'll multiply it by the last thing, x plus 5. And by the way, the order doesn't even matter. Multiplication is what we call commutative, which means that the order that you multiply these things doesn't really matter. But I don't know, we read from left to right, so sometimes I get in the habit of working from left to right. All right, so what we're going to do is that we're going to take these first 2. So I'm going to take x minus 3, and then I'm going to take 2x plus 4, and I'm going to multiply those things together. Now the way the box works is that you just take x minus 3, so each term gets its box. I could have put x minus 3 on the side. Order doesn't matter here. 2x plus 4. And then what we're doing is we're multiplying what's on top by what's on the side. So x times 2x, which would give us 2x squared. And then we'll multiply 2x times negative 3, which gives us negative 6x. And then x times 4, right? What's on top, what's on the side. So that would be a positive 4x. And then what's on the left, what's on top, which would be a negative 12. Now at this point we want to combine some like terms, and maybe we'll clean this up a little bit. Not liking the way that looks. You know, part of what we want to make sure we do is that we can read our own handwriting. I'm guilty of it myself sometimes. Can't even read my own handwriting. So let's make sure we can read what we're writing. And it's even worse. Maybe not. All right, there you go, 4x, you got it. So what we want to do is we want to combine some like terms. So you've got a positive 4x and a negative 6x. There we go. And then what I'm going to do is I'm going to take what's left there. So I've got a 2x squared. And then what I highlighted there is a plus 4 and a minus 6, right? So I have, there's more negatives and there's 2 more negatives, so that would be a negative 2x and then minus 12. And then what I'm going to do is I'm going to take that and now multiply it by the third group, right, which is x plus 5. So it's really kind of 2 problems in one. You're having to multiply these 2, get an answer, and then multiply it by the third. Well, what I'm going to do is I'm actually going to set up another box. Now, because there's 3 to that particular answer, 2x squared minus 2x minus 12, then I need a rectangle here that's going to have 3 boxes. So I'm going to take the answer that I just got right here, which is 2x squared minus 2x minus 12. All right, so let's take that, 2x squared minus 2x minus 12. And then we need to multiply it by the one thing that we haven't multiplied yet. So we've multiplied, for instance, we've multiplied by x minus 3 and 2x plus 4. We just got to get that x plus 5 in there. And again, what we're doing is we're taking that as well. We're multiplying those 2 things together. And x plus 5. Now, just because we change the size of the box, it doesn't change how the box works. Still the same idea. What's on top, what's on the side. So 2x cubed minus 2x squared minus 12x plus 10x squared. And you don't have to write the plus necessarily. I mean, if you know it's positive, you just leave it like that. That's okay too. And minus 10x and then minus 60. Now, one of the reasons why I do like the box is that as far as when you go to combine your like terms, the like terms are kind of nice, lined up pretty nicely here, right? So, for instance, you got your like terms there as far as your x squareds, and then you got like terms as far as your x's. So we're just going to combine those things. So for a total there, I would end up getting 2x cubed, 10 minus 2, which would be 8x squared. Negative 10 and negative 12 means I've got a total of 22 negatives, and then negative 60. And that would be my answer. All right, well, so go ahead and pause the video here and try number 2 in the middle. You should have number 2 in the middle finished at this point, so let's take a look and see what you should have got with that particular one. So we're going to multiply the first two, and again, as we said for that last problem, the order doesn't matter. So let's just multiply the first two, though. So I've got x minus 1, and I've got 3x plus 2. And then we're going to multiply that out. 3x squared minus 3x plus 2x minus 2. Going to combine our like terms, and this is a good use of a highlighter right here to combine your like terms so that way it stands out for us. So we've got 3x squared. More negatives, right? So minus 1x, or you could just write minus x. I don't know, I'll write minus 1x, and then minus 2. And then we need to set up a second quadrilateral, right? A little geometry at you, right? 4 sides. Just the difference is that's a square. Sides are supposed to be equal, whereas you got a rectangle here. So let's take what we got from the first one, 3x squared minus 1x minus 2, and we'll put that up top. 3x squared minus 1x minus 2. And then we're going to just take the other thing that we need to multiply, right? So we need to multiply x plus 4. We haven't done x plus 4 yet. And, of course, that's what we put on top. So let's take x plus 4. That's going to go to the side. And then we're just going to multiply. So 3x cubed. And I should mention, too, sometimes people say, like, oh, drawing the box is too much work. But I don't know. I would say that once you actually get it set up, that you can go through here pretty quickly and do your multiplying. Because it's organized. And I think for some people that are maybe a little more visual, I find that they like the boxes just for that reason right there, because it's nice and clean and organized. And then when you take a look at it, you say, well, what's left over here? Well, it looks like we got 3x cubed. 12 minus 1, which would be 11. Negative 4 and then a negative 2, which would be a negative 6. And negative 8. All right, well, once again, go ahead and pause the video here and try number 3 on your own. All right, so we should have number 3 finished there. Or, I keep saying that. Number 2 on the middle side. And let's look at number 2 on the right side. Same deal. You're just multiplying some numbers out. So I'm going to set up my box. And I've got x minus 2. And that will go on the top. And again, we said the order doesn't matter. You can put it anywhere. 4x plus 1. And then again, you're just multiplying what's on top by what's on the side. What's on top by what's on the side. So that would be 4x squared. Minus 8x plus 1x and minus 2. Combine your like terms, right? You got those like terms to combine. And so what we've got is 4x squared minus 7x minus 2. Set up our other rectangle. Now, if you're going to make a mistake on this, usually it's just with arithmetic. You multiplied wrong, you added wrong. Kind of a silly little mistake. So we just have to be careful with that, because that is a really easy mistake to make. All right, we're taking that and multiplying that. So let's throw that on our box. 4x squared minus 7x minus 2. So I think you'll get the idea of, setting up the box. Maybe it's something little like this. Like maybe you say 5x squared. Because you're thinking, oh, 4 and 1. Well, no, you're multiplying, right? So that would be 4 times 1. So just be careful with maybe kind of little mistakes like that. That's usually what's made. So 4x cubed minus 7x squared minus 2x plus 12x squared minus 21x minus 6. Not sure why I started singing, but I don't know. There you go. Try to keep you entertained. So let's combine some like terms. Or maybe it's just fun. I don't know. You having fun? It's fun doing some math problems. So there's your x squareds. There's your x's. And so we get 4x cubed plus 5x squared minus 23x minus 6. And there you are. So hopefully that's what you got. Hopefully. Right. All right. Well, so let's go ahead and take a look at number 3. So the first problem was adding, by the way, and we should have kind of set this whole thing up. What we're doing is we're just doing basic operations with groups, things called polynomials. Poly just means many, so we're just talking about groups of things. So adding groups, multiplying groups, which is what we did in the last problem. And then the third variation here is that something where we're dividing groups and we're doing long division. But let me just take you back over to the top right corner just to get you kind of thinking about how you even do long division. So just kind of go back to elementary school where you've got 68 divided by 2. Well, the first thing I would want to do with this one is I would want to write it how that problem is written, which is come with the long division symbol there. And then so what I have on the outside would be 5x plus 2. What's on top would be 15. I'm sorry. That would not be on top. That would be on the inside. Let's try that again. 15x cubed plus 31x squared minus 10x minus 10. All right, and I'm going to move this because this problem's going to end up kind of running down the page a little bit. So I just want to move this up a little bit. So let's move it, gives ourselves a little more room. Good enough. All right, so let's think about when you divide just even basic numbers like this, right? Like, so what you're trying to say is you're trying to say what times 2 makes 6, right? What times 2 makes 6? Well, 3, right? 3 times 2 is what makes sense. So kind of in the same way of what we just said there, we're going to do the same thing here. But in this case, we're not saying what times 2 makes 6. We're saying what times 5x makes 15x cubed. So what could I multiply 5x by to make 15x cubed? Well, you could multiply, you'd have to multiply by 3. 3 times 5 to get the 15. And then what times x to make x cubed? Well, you need 3 of them. You've got 1, so that means that you would need 1 more, right? So for 3x squared. By the way, you notice that I went in 1, so you're like, hey, why didn't you write the 3x squared over 15x cubed, like right here? Well, the reason being is because there's 2 terms on the outside here, we're having to kind of go 2 terms deep, right? So since there's 2 terms there on the outside, we're kind of going too deep. All right, and by the way, and then you're like, oh, hey, what about the 2 and all this other stuff? All we worry about is first and first. First on the outside to make the first on the inside. We'll get to all this other stuff. Just worry about the first and the first. Now, come back to our little elementary school problem over here, right? What do you do once you got the 3 up there? Well, you multiply 3 times 2, which is 6, right? Well, we're going to do the same thing. We're going to multiply. So we're going to say 3x squared times 5x. Which would make 15x cubed. And we're going to say 3x squared times 2. Maybe we'll draw an arrow there to make sure we're getting a good visual on that. Right? Because you're having to multiply, because there's 2 things on the outside, you have to multiply both of those things. So you would end up with 6x squared. Now, go back to elementary school problem over here. What do you always do when you get to this point, right? You subtract. Take the difference of those two things. Well, we're going to do exactly the same thing. We're going to subtract. But the difference here is that because there's two terms, I have to do that for both of them. Not just one of them, I have to do it for both of them. So what ends up happening there, and it shouldn't be a surprise, what ends up happening there is that the x cubes cancel each other out. Again, no surprise, we wanted that to happen. 31 minus 26, or I'm sorry, 31 minus 6, which would be 25. So let's say 25x squared. Go back to elementary school problem over here. Right? 6 minus 6 is 0. What would we do now? Well, you bring, if there's anything else still up there, you bring it down. So we're going to bring down the 8. Well, we've still got some other stuff up here. We're going to do the same thing. So what we're going to do in this case is that we're going to bring down whatever's next here, which would be a negative 10x. So bring down that negative 10x. And then the whole process starts over here, right? So you go back to the very beginning, just like with our elementary school problem. You start over and you say, okay, now I'm looking for what times 2 would make 8. Well, which we know is 4. And then the process repeats itself till you get a 0 remainder. Well, so kind of same thing over here. The process repeats itself. The difference, however, is that now what I'm saying is I'm saying what times 5x, right? Because it's always the first thing on the outside to make the first term on the inside. Well, we already knocked out the first term on the inside. There's a new first term on the inside. It is now 25x squared. So what we want to say is what times 5x makes 25x squared? Well, that would be 5x. And I don't know, let's say if you're not sure if you got that right or not. Well, multiply it out. That's why we multiply, right? One of the reasons to make sure we got this right. So 5x times 5x, which would be 25x squared. Okay, we got it right. 5x times 2, which would be 10x. Don't cancel those 10x's yet. I know you want to. The reason why we can't cancel it yet is you got to do the opposite. You got to switch the signs. Right, so what we're doing there is that we're switching both signs. I'm going to make a little note here. Switch both signs. Because see, that's what we did right there, and that's what we're doing right there. We do it every time. Now, as far as what cancels, those x squareds cancel, and you notice that's why I didn't tell you to cancel the x's. Well, because it's actually now a negative 10 and a negative 10, so that'd be a negative 20x. And let's see who's to bring down. Oh, hey, Mr. 10, come on down. Actually, Mr. Negative 10, right? So we'll bring down that negative 10. Process repeats itself. So yeah, it's one of these things that looks kind of scary at first, but I think once you get the pattern down, and then it kind of just repeats itself. So what we're saying now is we're saying what times 5x would make negative 20x? Well, it would be a negative 4 that would make negative 20, right? And then negative 4 times x, right? So yeah, that makes negative 20x. And then negative 4 times 2, which would be a negative 8. And again, don't say, you're like, hey, well, they don't cancel. Well, because we haven't switched the signs yet, right? Once you switch the signs. And when I say switch signs, by the way, positive turns negative, right, which was the case over here. But if it's already negative and you switch it, then that means it becomes positive. So those would cancel each other out, and we would get a remainder of negative 2. Well, so we don't have anything else to bring down. We have a remainder. And we're not going to do the baby elementary school thing of writing r negative 2. We're big kids. So what we end up doing is that, I don't know, think back to what you did with even just regular numbers, right? So let's say if you had, let's say we're saying 7 divided by 3, for instance, right? And you get a remainder of 1. What would you do with that? Well, if you don't quite remember from elementary or middle school, what happens if you have a remainder is we write this as a mixed number. So what ends up happening is that the remainder, whatever that is, becomes the numerator of a fraction, numerator being the top number, and then whatever's up there kind of comes in the front, right? So that would end up being 2 1/3. So kind of same situation here. This is going to be, the remainder is going to be the numerator, so this would be a negative 2. And then what's on the bottom is whatever was on the outside. Because see, over here what was on the bottom was a 3. So what's on the outside here would be 5x plus 2. And may be kind of a strange looking answer, but that's what it is. And one last thing to note with that one is you might wonder, why is the negative on the outside like that? Because you're saying, hey, I thought it was a -2. Well, you know, when a fraction's negative, it's not really that the top's negative or the bottom's negative, it's that the whole thing is negative. So how I end up writing that is the negative just gets thrown out front. Right? All right, so and I got to tell you, man, these problems are kind of a bear. These problems are difficult. It's a lot of little tedious, a lot of little steps that you're having to work through here. But like I said, once you get the pattern down, I think you'll find that it's not as bad. It looks scarier than what it maybe really is. All right, so let's go ahead and pause now and try number 2 in the middle. Okay, well, let's check on how you did. And I'm guessing if you made a mistake, it was probably that little stuff. And that's not just for this. I mean, that's a lot of things in math for us, is that a lot of times we think that we don't understand how to do something, when in reality you actually maybe really do know how to do it. It's just that you maybe made a little arithmetic mistake, maybe you added wrong, you multiplied wrong. So those kinds of things can happen, so we just have to be careful not to make those mistakes. I'm going to do the same thing here, make myself a little room, so get that out of here. Sometimes they'll be nice and go ahead and write it for you in this form with the long division. Sometimes they are big mini heads and you got to write it this way yourself. That's all right, we're big kids, we can handle it. All right, so again, the key on this one is first and first. First on what on top can I multiply by to make the first thing on the outside multiply to the first thing on the inside. So I'm asking myself, what times 2y? And again, don't look at that 2, don't look at this, any of this other stuff. Just focused on this. What times 2y would make 2y cubed? Well, that would be y squared. And remember, you got to multiply. So y squared times 2y would be 2y cubed. And then y squared times 2 would be 2y squared. So I'll say plus 2y squared. Now you have to make sure that you switch the signs every time. So switch the sign there, switch the sign there. These will end up canceling each other out. No surprise, that's what we wanted to happen. If I have 4 negatives and 2 more negatives, now I've got a total of 6 negatives. And let's see who needs to come down. All right, negative 12y, join the party. So negative 12y will bring on down. And then, again, process repeats itself. What can I put up here that when multiplied by 2y makes, in this case now, negative 6y squared? Well, what times 2 makes negative 6? That'd be a negative 3. I'm trying to make a y squared. I've already got 1y right there. That means I just need one more y, so negative 3y. And, as I said, multiply it out. You know, if you made a mistake, you'll be able to catch it right here, because if these two terms do not cancel each other out, then that's where your mistake was. So hopefully you'll be able to catch that. All right, switch the signs. And because I know that this is, I'm going to write this, because I know this is one of the biggest mistakes that people make, is they just forget to switch the signs. So I really want to emphasize that. Switch both signs. So that would become a positive. That would become a positive. Those cancel, and we've got negative 6y. And let's see, negative 8, come on down. So we'll bring down negative 8. And once again, starting back over. What times 2y, let's see, what are we trying to make this time? Oh, negative 6y, that's what we're trying to make. Well, so that would be a negative 3. Multiply it out, negative 3 times 2y, which would be a negative 6y. Negative 3 times 2, which would be a negative 6. And we know we're not canceling yet, because we know we've got to switch some signs. Let's switch that to a plus. We'll switch that to a plus. And then now we can cancel. And negative 8 plus 6, which would give us a negative 2. So we have a remainder there of negative 2. All right, well, so let's see what that would give us. Kind of the same deal. Right, so you got minus and then 2 over 2y plus 2. 2y plus 2. Kind of a weird looking answer, but that's what it is. All right, well, hopefully you got that. If you didn't get that, hopefully it was just that maybe there was a little mistake, somewhere in here, but, hopefully you got kind of the idea of what we're doing. All right, well, pause now, and let's try number 2 on the right side. And at this point, you should have number 2 on the right side finished. So let's check your work and see what you would have ended up with this one. 5z plus 5. Don't you love long division? Nothing better on a whatever afternoon it is for you. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, whatever day of the week. Right? Nothing better, though. It's a Monday for me. Nothing better on a Monday afternoon than doing a little long division. Yeah, I have to admit, I mean, these can be a little rough, but again, once you get the pattern down, it's not too bad. But you know what? If you can do this, then you can do. There's a whole lot of stuff you can do if you can do this. All right. So again, hopefully we got this idea first and first, right? What's the first thing on the outside we can do to multiply the first thing, or to make, right? We're looking for a product of those two things. What would equal the first thing on the inside? Well, I already got the 5. Say I need 3 z's. There's 1, so I need 2 more. So that would be z squared. So we'll say 5z cubed. And this long division, by the way, out of everything that's on this study guide, this by far is the most labor intensive as far as requiring the most amount of work. Everything else I think you'll see is not as bad. We're going to switch the signs, and I'm going to make my same note this time. Switch both signs. So we're going to switch them there. And z cubes canceled, so I've got 10 minus 5, right, because that turned into a negative. So that would be 5z squared. And let's bring down that 10z. So that would be plus 10z. And let's start it over. What times 5z makes 5z squared? And I keep underlining this, by the way, because I'm just trying to draw your attention to that we're just focusing on those two terms. We're not worried about anything else. We'll get to that. But that's all we're worried about at this point. Well, what times 5z would make 5z squared? Well, again, we already got the number. We're just short a z. So we'll do a z there. By the way, I hadn't mentioned that yet. As far as being able to read your own handwriting, a 2, that's my 2. Do a little line through the middle for a z. Some people do it the other way. Some people will put a little line through the 2 and then no line on the z. But you should have some way of doing that so that you make sure that you don't make a mistake of thinking it was a z or when it was a 2 or vice versa. All right, so let's see here. 5z squared plus 5z. We know we got to switch. So let's switch them. Right, switch those signs, and then we see that the z squareds cancel. 5z, who's coming down? 3, welcome, my friend. 3's coming down. And last time, good riddance, last time. So let's multiply it out. So you see, we're looking for what times 5z would make 5z. Oh, well, I already have what I need, so if we're saying what times 5z makes 5z, well, that would have to be 1. Because 1 times 5z is, well, 5z. So let's see what our remainder is going to be. And by the way, so the question that's on the test has a remainder. If you've noticed that every single one of these have a remainder, well, that's because the one on the test has a remainder. What would be different if there wasn't a remainder? Well, you just, if this were a 0 remainder, then what's on top would be your answer. So it wouldn't really change anything about your answer. And let's see what cancels there. So again, a -2. I think this is 3rd time in a row we've had a remainder of -2. I don't know if that's intentional or not. 5z plus 5, and there you are. All right, well, let's go ahead and take a look at number, where are we at? Number 4. All right, number 4. All right, so it says the factor 16x to the 6th minus 25y squared. Now, what that means when we talk about factoring means what's the reverse, to go back and say, what did that look like before? So, for instance, what we're saying is that we did the box on this. There was two things that got multiplied together. You don't have to write this down yet. I'm just kind of setting this up for you. There was a group of 2 and a group of 2 that got multiplied. And when you multiplied those two things together, either because you FOILed it or you did the boxes, what we're saying is that something got multiplied, and then what popped out of that box is 16x to the 6th minus 25y squared. So the reason why I have this rewind button over here is that's what factoring is. It's to go back and say, okay, before it was 16x to the 6th minus 25y squared, it looked differently, right? So what did it look like before it got multiplied? Back when it was in parentheses. That's what we're trying to figure out. So we're just really kind of doing the reverse. Now, there's a couple different ways we can go about this. This particular standard for us in Algebra 2, we wanted to be able to notice a certain type of pattern, and then thereby there would be a shortcut way that we could go about doing this. And if you look at the top right over here, this particular type of pattern is called the difference of squares. The reason why it's called the difference of squares, difference because, well, subtraction, minus, this will always be a minus. So for instance, if this said a plus, it's not this kind of pattern. It has two terms, right, an A and a B, right? And then what ends up happening is that these are perfect squares, so hence the name difference of squares, meaning that we can take the square root of each one of those numbers. So let me clear this off, and we'll kind of show you the shortcut on this one. So all that you need to do is just take the square root of the first term, the square root of 16x to the 6th. Well, you know the square root of 16 is 4, and then you're like, what's the square root of x to the 6th? Well, think about what the square root means. What the square root means is what number times itself gives you the thing that's underneath the radical there, right? So, you know, for instance, what times what gives you 16? Well, 4. And then we're saying, well, what times what would give you x to the 6th? Well, that would have to be x cubed. And I could prove that, by the way, if I said x cubed times x cubed, that would be x to the 6th. So that's what we mean by taking the square root of that. And then we're just going to take the square root of the second term. Ignore the minus sign. Just put that as a positive 25y squared. Square root of 25 would be 5. What times what makes y squared? Well, that would have to be y. And then, so what this pattern tells me to do is that it tells me, I'm going to pull this over here. What the pattern tells me is that I'm going to put these in parentheses. So I would have, because my problem here was 16x to the 6th minus 25y squared. And so what I do is I take a and b. So a in this case was 4x cubed. I'll write that first. And then b, which is 5y. So I've got plus, I didn't give myself enough room here. Let me rewrite this. So plus, we're going to do it once as a plus. That's the only thing that's different. You see how this is once as a plus, once as a minus? Otherwise, you're copying the same thing twice. So 4x cubed plus 5y. And then you've got 4x cubed minus 5y. And that is what 16x to the 6th minus 25y squared looked like before it got multiplied out. How can I check this? Well, it's a real easy check, and not that you have to do this here. And I probably won't do this on the other problems because it's ends up being a little bit too much work. But I do want you to see this here because I want you to see what I'm referring to or what I'm talking about as far as being able to check this. So what I could do is that if I multiplied, right, this is a difference of squares. So what I could do is that if I multiplied this out, what I'm saying my answer is 4x cubed and 5y. 4x cubed minus 5y. And by the way, if you forgot this little shortcut, this would be something you could do on the test. If you look at multiple choice, if you look at A, B, C, and D, they'll have 4 different answers that look something like this. Maybe different numbers, different signs. But if you just multiplied it out, you could figure out which one the answer would be. So, for instance, if I multiply it out, I get 16x to the 6th minus 20x cubed y plus 20x cubed y. Didn't make a big enough box, and minus 25y squared. Well, see what ends up happening is those two end up canceling each other out, and then what do you have left? Well, what you have left is 16x to the 6th minus 25y squared. Hopefully, I don't know if that got cut off or not, but so yeah, I just want you to see that that's the significance of this answer. This answer is saying, what did it look like before it got multiplied? Well, that's what it looked like. And if you're not sure, you can just multiply it back out to see if it matches up. All right, so let's pause here and try number 4 in the middle. All right, so you should have number 4 in the middle complete at this point. So let's see what you got. Now, I'm not going to multiply it out. That was just on the first one. So I'm going to show you kind of how I want you to set this up on the study guide and how to do it on the test. Just take the square root of the first term, 49r to the 8th. Take the square root of the second term, which would be 100 t to the 4th. Well, you know, the square root of 49, what times what makes 49? 7. And should have mentioned this on the other one. It's more than just saying what times what makes the number. It's what same number, right? 'Cause that's by definition of the square root. What same number multiplies to 49? Well, that would be 7. What same term would multiply to r to the 8th? Well, that would be r to the 4th. What same number multiplies to 100? Well, that would be 10. What same term multiplies to t4? Well, that would be t squared. And then again, let's put this in parentheses. Give myself a little more room this time. So it's the same thing twice. 7r4, 7r4. Just once is a plus, once is a minus. By the way, order does not matter. It doesn't matter if you did minus then the plus, plus then minus. It's all the same thing. 10t squared, 10t squared. So if we wanted to know what did 49r to the 8th minus 100t to the 4th look like before it got FOILed, or before it got boxed out, before it got multiplied, well, that's what it looked like. All right, go ahead, same routine. Go ahead and pause and try number 4 on the right side. Okay, well, let's check number 4 on the right side. So A and B, and by the way, A and B, those letters have no significance. It's just A is just representing the first term, B is just representing the second term. So there's no significance to using those letters. So I know you're looking at it and you're like, hey, well that says M and Y. Well, those are the variables within the problem. So just don't get hooked up on that. All right, so A equals 64, or square root of 64m to the 10th, right, which would be 8m to the 5th. And let's see, B, square root of 9y squared, which would be 3y. All right, so difference of squares. And how I recognize difference of squares, it's got two terms that are always being subtracted. That's where the difference part comes in. And squares being they're numbers that are perfect squares, numbers that I can take the square root of. So 8m to the 5th goes twice, 8m to the 5th. And only difference here, once is a plus, once is a minus. And then the b, the second term, which would be 3y. And if I wanted to, if I just had absolutely nothing to do, or not just if I was bored, maybe I wanted to check my answer, you could multiply this out. And again, if you forget this shortcut, the other tip here is that if you multiplied out A, B, C, D, that's another way to get the answer. All right, well, let's go ahead and take a look at number 5. So number 4 was factoring one type of pattern that was called a difference of squares. We looked at another kind of pattern. This particular pattern, if you look at the top right over here, it's called the sum and difference of cubes. So cube just means something to the third power. So that should stand out to you right away, because you see that it's not something to the second power, it's something to the third power. So what we're going to end up doing is we're looking for, and it's kind of a different pattern. By the way, if you notice over here on the right side, so you see difference of squares. It's the same thing twice, just once is a plus, once is a minus. This one you notice is a little different. It's actually a binomial, a group of 2, and a trinomial, a group of 3. So that's what this particular kind of pattern is. Well, how we work backwards, we're trying to figure out what did this look like before it got multiplied out. Well, what I want to do is I want to take the cube root of 2. And when we think about the cube root, just mention this real quick. The cube root of a number, I don't know, let's say 8 for instance, right? If you don't see a number out here, then it's implied or it's understood that that means the square root. But if we take the cube root of something, what we're saying is we're saying what times itself, what same number, not 2 times, but what same number 3 times would give you the number that's underneath there. Well, that would be 2, right? Because 2 times 2 is 4, times another 2 would be 8. So that's the idea of the cube root. Some of the most common cube roots that you'll see, cube root of 27, what number times itself 3 times? Well, that would be 3, because 3 times 3 is 9. 9 times 3 is 27. So that's the idea of the cube root. Well, I can't take the cube root of 2. So what I always have to check for any time I'm factoring is that maybe before this thing even got started, maybe there was a number on the outside that got distributed to something on the inside, right? So we think of that as our greatest common factor. So, well, there's a 2 that goes into both of those, so there must have been a 2 on the outside first that got distributed in. So almost think of it as like an extra number, right? And you maybe say, well, why didn't we do that on the last one? Let's go back to look at this last one on number 4. You notice that there's not a number that goes into 64 and 9, so there was no greatest common factor. Not a number that goes into 49 and 100, right? So that's why on number 4 that wasn't an issue for us, is because there was no greatest common factor. On number 5, there is a greatest common factor. Now, what do you do with it once you got the greatest common factor pulled out? Well, so this is where you're going to take the cube root of, and not square root, right? Because we're talking about the cube root. How would you remember that it's the cube root? Well, it's to the 3rd power. Hopefully that's a little easy way to remember that. So this says what times what times what makes x cubed? Well, that would be x, right? Because x times x times x would be x cubed. All right, what times itself 3 times would give you 125? Well, it works out to being 5 times 5 is 25, times another 5 would be 125. So that actually would be 5. 5 to the 3rd power gives you that. All right, now what's the pattern on this one? Pattern works in the first part of it's kind of the same, because you've got, no, I'm going to have to give myself a little more room. You take what you got there, x and 5. But what's a little bit different about this one is that you notice that the a and the b, and I'm looking up here at the top right, so you notice that the a and the b is what goes first, and then the second pattern says a squared, so that means that you square the first number. So if we square the first, that would be x squared. Look over here at the pattern. Then it says a times b, and then it says b squared. So we square the first, you square the last, so the last one in this case, which would be 5, so square 5, which would be 25. Again, notice where I got the 25 from. I squared x to get x squared. I squared 5 to get 25. And then the middle term is a product of the two things. We multiplied them together, a times b. So if I multiply these two things together, I get 5x. Now, a little shortcut we came up with in class, way to remember this, is you square the first, so x squared, square the last, so 5 squared, 25, and then you multiply the two real fast. 5 times x, which would be 5x. So that was square the first, square the last, multiply the two real fast. Now, another little trick to remember the signs on this one. See the guy over there, the soap dude. So this would be, what SOAP stands for is a little mnemonic device to help you remember the signs of what this should be. So the S stands for same. So same is whatever is in the problem. So in the problem there's a plus, so that would be a plus. O stands for opposite. So opposite of whatever is in the problem. so that would be a minus. And then AP stands for, not assistant principal, stands for always positive, right? So that's SOAP, same, opposite, always positive. If I wanted to, how could I check to see if this was the right answer? I could multiply this out. Oh, and actually we forgot somebody. Our greatest common factor that was hanging out front the whole time, we have to make sure he gets represented there as well. So our greatest common factor would be hanging out front. So again, how could I check this? If I multiplied all of this out, if I did, set up a box, I would end up getting 2x cubed plus 250. All right, so let's go ahead and pause it here and try number 5 in the middle. All right, well, let's check it out and see what you got for number 5 in the middle. So again, checking for a greatest common factor. Looks like there's a 3 that I could factor out. So I'm going to factor out a 3 first. So I'd end up with y cubed minus 27. And so our a would be y cubed, right? The first thing that we're taking the cube root of. Cube root of y cubed, which would just be y. Cube root of 27, which would be 3. And here's our pattern on this one. So you got the greatest common factor of 3. Let's not forget that one. Forgot that last time. Almost forgot it. So you take the first term, y and 3. And here's the pattern. Square the first. So y would become y squared. Square the last. 3 would become 9. And then multiply the 2 real fast. Actually, I got to say that kind of fast, so let me back that up. Right, because the whole trick here is square the first, square the last, multiply the 2 real fast. Well, I didn't even try to write that fast. Not that you have to write it fast, but maybe it makes it a little more interesting. Maybe not. All right, so let's check out the signs. So, Mr. Soapman, please tell me the sign. All right, what does Soapman say? Well, same as what's in the problem. So that would be a minus, opposite would then be positive, and then AP always positive. Again, if you wanted to multiply that out, you could verify that would be the answer. Looks good to me, though. All right, well, once again, try number 5 on the right side. Okay, well, let's check, see what you got with number 5 on the right side. Again, checking for a greatest common factor. You might say, hey, we can divide it by 2. Well, there's a reason why we call it the greatest common factors, because we're looking for the biggest number that would go into both one of these. Well, the biggest number that would go into 4 and 32, well, would be 4. So we could factor out a 4. We're left with z cubed plus I almost said 8. Same thing, right? And let's take the cube root of the first term, z cubed, which would be z. Cube root of the second term, which would be what times what makes 8? That would be 2. And so we got our greatest common factor, and then let's put it in the parentheses. So I got z and 2. Are you ready? Square the first, square the last, multiply the 2 real fast. Square the first, square the last. Oh, man. See, that's what happens. You try to start doing it too fast, and you make mistakes. Try that again. Square the first, square the last, multiply the 2 real fast. And let's bust out the soap. And don't drop it. Don't drop the soap. So same should be plus, opposite minus, always positive. And there we are. All right, well, hey, halfway there. A little over halfway there, right? So we already got to knock down the first 5. I think you'll see the next couple, one of these is actually pretty easy. So let's look at number 6. It says find the sum. What does sum mean? Well, sum means to add. I want you to do something. I want you to circle that word sum, and I want you to write add. Because what's going to be real tricky about this, you'll notice this one and the next one, or number 8 rather, it's written very similar. They just change a word. Instead of sum, they say product. So we just want to be really careful about that. Sum just means to add. And so again, kind of going back to our apples, looking up here at the top right, so you see 3 apples plus 1 apple. Well, that would make 4 apples, right? So we're doing kind of the same thing as far as this idea with the apple comparison is just to say that you're adding or combining like terms. So 6 minus 3i plus negative 2 plus 4i. Add them up. 6 minus 2 would be 4. And negative 3 plus 4, which would be 1. Or we could just write I. Okay. And you might be wondering, hey, well, what's the deal with I? Well, so we should mention at this point that the next part of what we're going to look at are imaginary numbers. That's what I stands for. But when it comes to adding i's, subtracting i's, multiplying i's, in a lot of ways, it's very similar just as if it were an x. So for instance, had this problem said 6 minus 3x plus negative 2 plus 4x, it'd be the same thing, right? Like 4 plus 1x, or just 4 plus x. So really, I, in a lot of ways, gets treated just like x, y, z, or any other letter in the alphabet. So if we're adding it up, that's all we're doing there. And by the way, as far as where we saw imaginary numbers, actually, maybe we'll talk about that a little bit more in the next problem or two. So we'll just leave it here at this point. That just add it up. Pretty simple. All right, so go ahead and try number 6 in the middle. All right, so should have number 6 in the middle at this point. So let's just line them up, stack them up, and add them up. So you end up with negative 2 plus 4i. Easy stuff, right? Go ahead and try number 6 on the right side. Well, and this is nice, right? Compared to the long division, it took 10 minutes for one problem. We're able to throw these down pretty quickly. So let's go ahead and look at, you should already have number 6 on the right side done, so let's go ahead and look at it. So this says the sum, again, sum means to add, 8 minus 5i, negative 4 plus 6i. Let's add them up. 8 minus 4 would be 4. Negative 5 plus 6 would be, and you could write that, by the way. You could write 1i, that's okay. Or you could just write, formally how you would see it is you would see it as 4 plus I. But that's okay if you put 1i, that wouldn't be wrong either. Alright, so well, that was easy. Let's try number 7. And this will be easy as well. We got to set this one up a little bit. So let's go back over to the right side over here. So I is equal to the square root of negative 1. Where did that even come from? Well, if you remember back when looking at solving quadratic equations, and I'm just going to kind of make something up here. But, let's say you had something that looked like this. You got an answer after you did the quadratic formula. Let's say you got an answer that looks something like this. And in Algebra 1, we told you, well, you can't take the square root of a negative number, so the answer would be no solution. Well, one thing we kind of left out is that it's technically that there's no real solution, but there is an imaginary solution. See, I can't take the square root of a negative number because by definition, as we said a while ago, that it's what same number multiplies to the number that's underneath. Well, you think, oh, 4 and negative 4. Well, true, that does multiply to negative 16, but it's not the same number. So what we have to end up doing is we have to separate this. 16 is fine. I can take the square root of 16. It's just that I can't take the square root of a negative 16. But what if I do is if I separate this thing, if I kind of pull it apart, and I say, well, just give me the 16 as a positive, and then you can have the negative over there, then I can work with 16. So for instance, the square root of 16 is 4. And then you've got this 4 square root of negative 1 that we can't do anything with. Well, we get tired of dragging around the square root of negative 1. So as a shortcut, instead of having to write the square root of a negative 1 every time, we write the letter I. So I is equal to the square root of negative 1. So for instance, this would be equal to 4I. No, we can't read that. Move this out of the way. We'll get to that in a second. So yeah, 4 instead of saying 4 times the square root of negative 1, we would say 4i. Okay, so that's where we first saw imaginary numbers. That's where we first saw I. Now, what we came to see is that I squared. If you talk about some of the higher powers of I squared is equal to a negative 1. And part of that would be part of the proof on that is that if I wanted to get rid of the radical, if I squared one side, if you square something that's already has the square root on there, those two things kind of cancel each other out, and so that's how you're left with just the negative 1, and so I squared is equal to negative 1. Alright, so with all that said, so that's kind of the background on complex numbers, imaginary numbers, where that came from. So we want to know what I to the 43rd power is. Well, all we know that I to the first power is, well, we know anything to the first power is just itself, so we know I to the first power would just be I. We know that I squared is equal to -1, right? Because this is a given. I squared is equal to -1. And by the way, don't worry, we're not going to count this all the way out to 43. What we're going to look for is we're going to look for a pattern, and then once we figure out the pattern, then we can come up with a shortcut. Well, I cubed, for instance, what would I cubed be? Well, I cubed is a combination of I squared and I to the first. So if I, right, because I squared times I to the first, well, so that would be I squared would be -1, and I to the first is just I. So that would be a -I. All right, what do you think about I to the fourth? Well, I to the fourth would just be I to the third power, which we know is -I, times I to the first. See, I'm just trying to get the exponents to add up, right? 2 and 1 to make 3, 3 and 1 to make 4. We know that I to the third power is -I, and we know that I to the first power is I. So then that would be a negative. Oh, wait, hold on. Let me back that up real quick. Well, we actually don't have to back that up entirely. We can kind of continue with our thought here. -I times I would be a -I squared. And we know that I squared is equal to -1. So -1 times -1 would be a +1. Okay. All right, and then so what would I to the fifth power be? Well, so I to the fifth power would be I to the fourth power times I to the first power. Well, we know that I to the fourth, as we just figured out, is 1. Maybe we can kind of highlight these so we can kind of see what's happening here. So it goes I, -1, -I, 1. And then, so I to the fourth would be 1, and I to the first is I. So that would be 1 times I, or it would be just I. So what you notice is that the pattern started back over. See, we started with I, now we're back at I. So for instance, and maybe we can kind of see this just one more time. So let's say we said I to the sixth power. Well, so I to the sixth power would really be I to the fifth power times I to the first power. Well, we know I to the fifth is equal to I, and then we know that I to the first power is I. I times I would be I squared. I squared is equal to a -1. So notice here what happened is that it went from I, -1, I, back to -1. So what ends up happening is the pattern ends up repeating itself every 4. So if it repeats itself every 4, then what that means is that every multiple of 4 would be equal to 1. So for instance, I to the 8th would be equal to 1, I to the 12th, 16, 20, and so on. So here's a little cheat sheet down here just to take a look at it. What we're going to do is that we're going to take whatever the number is, the exponent, which in this case is 4, and we're going to, 43 rather, and then we're going to divide it by 4. So I'm going to say 4 into 43. Again, why am I dividing by 4? I'm dividing by 4 because the pattern repeats every 4. So again, it goes I, -1, -I, 1, right? And then so on from there. So it repeats every 4. So what I would probably want to do, and let me maybe just kind of clean this up for you so we can kind of summarize what we just did here, is I'm going to want to write this down. So as soon as I get the test, I'm going to want to write this pattern down, because you will have to remember this pattern, because it is important to remember it. You won't be able to, you wouldn't be able to figure it out either way. So I to the first power is I squared is equal to -1, I cubed is equal to a -I, and then I to the fourth power is equal to 1. So, and then it repeats, right? So it repeats so for instance, I to the fifth power would be equal to I to the sixth power equals negative 1. I to the 7th power equals negative I. I to the 8th power equals 1. And then we could keep doing that. We don't need to, but so it repeats every 4. So that's why we're dividing by 4. Let's divide it by 4. And so we get a remainder of 3. So what we do is that we then take a look at the remainder. And this is, by the way, how we would show our work for this. So we have a remainder of 3, which means that if we get a remainder of 3, the answer is negative I, because that number matches up. The 3 in the remainder matches up with the 3 that's in the exponent. Right? All right, so go ahead and pause here and try number 7 in the middle. Okay, well, let's try number 7 in the middle. Again, this pattern repeats every 4. This pattern from I, negative 1, negative I, positive 1 repeats every 4. So we're going to take whatever the exponent is and divide it by 4. Because we're just trying to think if, because if you did 4, 8, 12, 16, 20, 24, right? If you counted all the way up near 65, then you would know every multiple of 4 would be equal to 1. And then, so we're just trying to find out what's the distance from that, the closest multiple of 4. So we get 25, which we could go in 6 times, which would be 24. By the way, whatever number you get up top, 16, that has no significance. What we're really after, what we're really looking for, is what's the remainder. So whatever the remainder is, that's what we're focusing on that would tell us what the answer is. So a remainder of 1 would tell us that the answer would be equal to I. So I to the 65th power would be equal to I. Okay. All right, well, go ahead and pause here and try number 7 on the right side. All right, well, let's go ahead and try number 7 on the right side. We got I to the 102nd power, I to the 102. So we're going to divide by 4. And we get 22. And let's keep dividing, and you get a remainder of 2. All right, so again, let's look at our little list here. I squared would be equal to negative 1 because we're looking at the remainder, right? That number right there. And then, so what that means, if I squared is equal to negative 1, that means that I to the 102nd power would also be equal to a negative 1. Yep, that would also be that. All right, well, almost there. Let's take a look at number 8. Now, this is the one where I told you on the other one where we have to be careful. These evil people, what they're wanting you to do is they're wanting you to do this right here. Which, by the way, don't write this down because it's wrong. They're wanting you to do this, and you're like, yay. And they're so evil that this would actually be one of the multiple choices. Well, the problem with that, though, is what's wrong with that? Well, the problem with that is that this is find the product. We know that product, and go ahead and circle product. Product means to multiply. Product doesn't mean to add. Product means to multiply. So we are not doing all that. What we're doing is we need to multiply those two things together. Well, how do we multiply? Well, it goes back to what we said earlier, right? So what this really says is 4 minus 3i times a negative 8 plus 7i. Okay, well, so this goes back to what we said earlier. How do you multiply two groups of 2? Well, you could FOIL it out, or you could use the boxes. Since I used the boxes earlier, I will continue to use the boxes. So let's set it up. It works the same way as just like if you're multiplying x's. There's no difference there. So I would take, for instance, 4 minus 3i and negative 8 plus 7i. That's why I like the versatility of the boxes, is because it works in several different kinds of situations. Negative 8 times negative 3i, which would be a positive 24i. Positive 7i, positive 4, which would be a 28i. And then 7i times negative 3i, which would be a negative 21i squared. Alright, so same deal. Combine your like terms. Combine like terms there would be 28i and 24i. And let's see what we end up with here. So we would end up with a negative 32 plus 56i because the 24 plus the 28. And, oh, I'm sorry, not 56. Let's try that again. How about 52? It's getting a little late. And negative 21i squared. All right, well, here's the deal. So we know that I squared is equal to negative 1. Right? Because that's what we said. We established that. I squared is equal to negative 1. So what we do is that anytime, anywhere we see an I squared, we're going to replace it with negative 1. So what that means is that everything else can be the same here, negative 32 plus 52i minus 21, but instead of writing I squared, I'm going to write what it's equal to, which would be a negative 1. So see, all I did there is I just made that substitution. I squared is equal to negative 1. And I'm just doing that so that I can simplify this further. Because see, I know what I squared is equal to, so I could say, well, that would be negative 21 times negative 1. That would be a positive 21. And then if I combined these two terms right here, negative 32 and a positive 21, that would give me a negative 11. So I would end up with a negative 11 plus 52i. Negative 11 plus 52i is what we'd end up with there. Okay. All right, so we'll go ahead and pause and try number 8 in the middle. Okay, so should have number 8 in the middle finished. So we're going to multiply 2 minus 2i. Let's set up our boxes. 2 minus 2i times negative 6 plus 5i. Negative 6 plus 5i. All right, so let's multiply this out. So you get a negative 12, right? What's to the side? What's on top? Which would be a positive 12i. What's on the top times what to the side? So that would be a positive 10i. And 5i times negative 2i, which would be a negative 10i squared. Well, let's combine some like terms. Got some i's there in the middle to combine. So if we did that, that would give us, nope, go away, Mr. Highlighter. Let's go back to pen. So that would give us negative 12 plus 22i minus 10i squared. Again, we're going to make this substitution here. We know that I squared is equal to negative 1. So anytime, anywhere I see an I squared, I'm going to replace it with negative 1. So negative 12 plus 22i. Oh, why don't I put a negative 1 right there? Well, it's only for I squared is equal to negative 1. So I, you just leave it as I. Just leave it alone. Don't touch it. So this is where we'd come up with a negative 1 to substitute. Right, substitute just means to replace. You think about like in sports, a substitution, one player goes in, another player comes out. So we're just, substitution just means to replace. So we're going to substitute, or we're going to replace I squared with negative 1, which would give us a positive 10 there. And let's combine our like terms. That's all we're doing there. We're taking a negative 12 and a positive 10, and we're combining those two things together. And then so we'd get a negative 2 plus 22i. By the way, it would not be incorrect if you wrote 22i minus 2, like if you switch the order around there. But the formal way that we write this is that we write the whole number first, the real number first, and then we write the imaginary number second. All right, so almost there. Let's pause here and try number 8 on the right side. All right, well, let's see what you got with number 8 on the right side. So let's multiply. Draw my big old box. And so what we've got, 5 minus 4i, 5 minus 4i, and negative 9 plus 8i. Well, let's multiply it out. Negative 9 times 5, negative 45. Again, if you make a mistake on these, it's probably just some arithmetic mistakes, so just be careful as you're going through here and multiplying. You can you probably have the idea of what we're doing here. You just got to be careful with how you multiply. add, all those kinds of things. So let's see here. We've got a negative 45 plus, we've got a lot of i's this time. 40 and 36 of them make a total of 76 i's. And then we got a negative 32 I squared. Move you over. So negative 32 I squared. Again, we're going to make our substitution. So I'm writing everything else as it is. Negative 45 plus 76i minus 32. But instead of I squared, I'm going to write negative 1. Let's plug in a negative 1 right there. So negative 45 plus 76i plus 32. And then we're just going to combine some like terms, just as we've done in the other two problems. Looks like I have more negatives, and I have 13 more negatives than I do positives, so that would be a negative 13 plus 76i. All right, well, let's go ahead and take a look at the next problem, number 9. All right, so number 9 is actually, this is the last problem where we have to do really any kind of work. And I think you'll see number 10. Number 10 is super easy. It will take us like 2 seconds to do. All right, so this is simplified. By the way, what we've done with these i's, these imaginary numbers, if you go back to what we've done on this study guide, is if you look back at number 6 was find the sum. So this was adding i's. If you look at number 7, this was reducing I to a certain power. And number 8 was multiplying i's. So the last thing, we've added and subtracted them. We've looked at i's as exponents. We've multiplied them. Now the last thing to do is divide, right? Because that's what the bar means. When you see that bar right there, that just means to divide. Now you notice some notes I put in up here at the top. To be reduced, fractions cannot have an imaginary number in the denominator. So what we want to do is we want to reduce this fraction, and we want to get the I out of the bottom there. So what we do is that at the top right corner, you'll see something that says multiply top and bottom by the complex conjugate. What that means is that we're basically going to multiply by the opposite here, because what we want to do is that we want to get rid of the I on the bottom. So the opposite of a positive I would be a negative I. But then we have this idea, you know, what you do to one, you got to do to the other, so we have to distribute on the top as well. Well, okay, so now on the top, as I said, we're just distributing, so you're just taking 4 and just multiplying it. So that ends up becoming 12 minus 4i. And then what we want to do is we want to look at what's happening on the bottom. So now on the bottom, this is a group of 2 times a group of 2. Well, if it's a group of 2 and a group of 2, a binomial and a binomial, right? Bi means 2. Then that's something we have to FOIL out or use the boxes, right? You got to FOIL or box it out. If it's just one number like 4, then that's just something you're just distributing, right? So that's nothing that requires all that much work. So what I might do is that, well, not might, I will come down here. I'm gonna do a little, a little kind of scratch work. So I'm gonna take 3 plus I and multiply these two things together. 3 minus I. So I get 9 plus 3i minus 3i minus I squared. Alright, so let's combine some like terms. Negative 3, positive 3. Oh, those actually cancel each other out, don't they? Well, and that should not be a surprise, because that was the whole point of what we're trying to do. We're trying to get rid of the i's. So no surprise there. What's left is 9 minus I squared. Now, we know that I squared, as we saw in that previous problem, anytime, anywhere you see an I squared, replace it with negative 1. So instead of writing I squared, I'm going to write what it's equal to, which is negative 1. Now be careful, there's already a minus there, right? So that minus is the minus that was already there. This negative 1 is coming from the fact that I'm substituting that in. Now the two negatives there, that really becomes 9 plus 1, which would be 10. So the denominator of this fraction would be 10. Now it is a fraction, so you're always checking to see if you can reduce. In this situation, you actually can reduce, right? You can divide everything by 2. So let me divide that by 2, let me divide that by 2, and then let me divide that by 2. And if you're going to reduce, it's kind of a package deal. It has to be something that goes into all of the numbers. So it can't just be something that goes into 1 or 2 of them. It's a package deal. It's got to go into everybody. All right, 12 divided by 2 would be 6. Negative 4 divided by 2 would be negative 2i. And then 10 divided by 2 would be 5. And that's what our fraction would be reduced. And we accomplished our objective of getting the I out from underneath the bottom. So the I is not on the bottom. It's on the top. That's okay. I'm just trying to get it out of the denominator. All right. And I should mention one thing before we go on to number 9 in the middle. It's always the opposite. So this was plus I, so I multiplied by a minus I. 3, a number is fine. So you notice that positive 3 stayed positive 3. So I'm not switching the sign of the number. I'm just switching the sign of the imaginary number. By the way, had this been a negative I, then I would multiply by 3 plus I. So you're just doing the opposite of whatever the I is. All right, so well, with that said, go ahead and try number 9 in the middle. All right, well, let's see what you would have got with number 9 in the middle. So this says 5 minus 2i. So I want to get rid of 5 minus 2i. 5's fine, actually. I'm just trying to get rid of the I. So that would be 5 plus 2i. So again, just remember, you're always doing the opposite of the I. The number's fine. Positive 5 stays positive 5. It's just the I we're trying to get rid of. And then I'm going to multiply by 5 plus 2i on the top as well. It's kind of our golden rule. What we do to one, we got to do to the other. Again, the top part, that's going to be fairly easy. You're just distributing there. So you've got 30 plus 12i. That's what you got on the top. Now, if you look at the bottom, 5 minus 2i times 5 plus 2i, that's a box. That's something you got to FOIL out. So let me get my box. Or if you're a foiler, some people are foilers. Foil away if you're a foiler. But I think what we've tried to do here is just show you the boxes, just so we're showing you one way. 25 minus 10i plus 10i minus 4i squared. All right, well, let's combine our like terms, which these cancel. Which, by the way, in this type of problem will always cancel, because that's the whole point of what we're trying to do. We're trying to get rid of the i's. So I've got 25 minus 4i squared. Also, this is a good little extra practice for if you're still struggling with being able to multiply two binomials, with doing the box here. A little extra practice for you, so that always helps. I squared for the 14th, 13th million time this time, maybe. We know that I squared is equal to -1. And so we've got 25 plus 4, which would equal 29. Now, in this case, the last one, you got something that you could reduce. Nothing goes into 30, 12, and 29, so that would be as far as you could take that one. All right, almost there. Pause it. See what you get for number 9 on the right side. Alright, so we should have number 9 on the right side finished at this point. Let's go ahead and check it. 5 over 4 plus I. So again, always the opposite on the I part. So this would be, you're multiplying times 4 minus I, doing that to top and bottom. And then what we want to do is we want to distribute. So let's multiply that out. And so we end up with 20 minus 5i. And then on the bottom, we've got 4 plus I and 4 minus I. So we want to multiply those two things out. And that's where we're going to hit our boxes again. Hit those boxes. So 4 plus I, 4 minus I. So 16 plus 4i minus 4i minus I squared. And again, at this point, you should be pretty good at multiplying this stuff, right? Because I mean, we've done this now, quite a few times throughout the course of the study guide. So you should be feeling pretty good about multiplying that stuff. All right, so let's cancel that out, which is good, right? That's the whole point of it. Through a little repetition, through a little bit of practice, this stuff hopefully starts to sink in. So 16 minus, but we know that we're not going to write I squared. We know that we're going to write -1. So that really, though, becomes 16, right? The two negatives really becomes 16 plus 1, which would be 17. Again, on this one, no number that goes into all three of those, so that would be as far as you could take it. So you have 20 minus 5i over 17. All right. Well, you made it, almost. But really, this problem is really easy. It's going to take like 2 seconds. All right, so this is graphing. You'll notice something that's different here is that instead of saying x and y, it says real and imaginary. So what you need to know about graphing complex numbers, in complex numbers, maybe we didn't define that earlier. We really should have. A complex number is just a combination of a real number and an imaginary number. So that's what all of this stuff has been. For instance, if we go back here, 20 minus 5i. It's a real number, 20, an imaginary number, the negative 5i. So that's all that means. All right, so let's see what you got here. Well, what we want to do is they want us to identify what that point is. Well, let's just go back to pre-algebra-ish kind of stuff. Like, what would that point be? Well, that point would be negative 3, because the x goes first, right? And this is going to be like our x. This is going to be like our y. So that point right there, for instance, that point would be negative 3, 4. If I was writing that in the traditional x comma y format. The only difference here is that the x is like the real number, the a. The y is like the second number there, the b. So how I would transfer that, if I wanted to transfer that into complex form, is I would write that as negative 3 plus 4i. Let me write that. Negative 3 plus 4i. And that would be my final answer there. So again, the first number is like the x, negative 3. The second number is like the y, positive 4. You notice the only difference here is that there's no comma. So what separates the two numbers is a plus or a minus sign. So there's no comma. Otherwise, it's written exactly the same way. And also, what you might see on this one as well is that sometimes it would be written in parentheses, negative 3 plus 4i. So just like that's written in parentheses, you could see it written that way as well. So those are the two different ways you could see that. All right, so easy stuff. Just figure out what it is first, like in just the normal xy that you're used to, and then you just have to rewrite it in complex form, and there's your model for how to do that. All right, so go ahead and pause and try number 10 on the middle. Okay, well, let's see what you got. We're looking for this particular point right here. So what's this guy's name? Well, again, if we were thinking in normal x, y sort of thing, it would be 3 to the right, comma, 4 down. So that would actually be 3, negative 4. All right, so if we're going to write that then, if we're going to take 3, negative 4, and we want to rewrite that in complex form, again, first number, the x, second number, the y, and then so what that would be is it would be 3, not plus, but in this case, because that's a negative, it would be 3 minus 4i. And that's what that point would be on the complex plane. Pause now, and you are almost home free. One last problem. I know you're sad. I know you want this to go on forever. But pause now and try that last one, and we're all done. Okay, well, let's see what you got with number 10. All right. Oh, I'm so sad. Don't want it to end. But all good things must come to an end. Looks like 4 to the left, negative 4. Looks like it goes up 2. So that would be, well, let me write it first in traditional form. So negative 4, comma 2 is what you would probably think of that as, negative 4, comma 2. But we know that if we want to write that in complex form, then that would be negative 4 plus, because that 2 is a positive, plus 2i. And that would be the only difference there. All right, well, you made it. Give yourself a pat on the back. Proud of you. You hung in there. And proud of you just for even, doing this video and working through these problems, doing the study guide. Thank you for caring enough to be able to want to come in, redo this so we can raise your grade. So we appreciate all those things and appreciate your time in watching, and hopefully you're able to learn some things you didn't know before, or maybe you just needed to kind of clear some things up. So hopefully this is a little more clear for you now. All right, well, you can go ahead and stop the video now at this point, and hopefully you're now ready to retake the test. So we'll see you next time.